Hello, this should be working. Okay. So we're gonna go over another one of the live problems just for the fun of it because I thought it was a really, really nice problem. The problem was, what is the biggest area of a rectangle that can fit in a graph of x squared plus y squared is equal to 25? And you might remember what this graph is from pre-calc or whatever class you've done in. It's a circle, just like that. And circles, we can use the property that they are symmetric. So imagine if we draw a little circle in here. This blue circle, it's right there. We can use the fact that we want, so we can analyze, let's say, this bit of the circle first, then this bit, and that bit, and that bit. And we kind of really abuse the symmetry properties of it. It's quite cool. And the area for our rectangle's area is equal to base times height. So we want to find the maximum area. When you look at the problem, you might be thinking, okay, surely maybe I can, because it says maximum, you could be thinking, oh, we could just do like add the derivative when the derivative is less than 0, but that's kind of weird. Okay, we're just going to keep it strictly, do nice algebra for now. So imagine there's a point here on the circle, which is at a maximum point. Let's call this point x, okay? Not x, actually. Let's call it gamma, okay? So the furthest distance from gamma to the other points, so we want to maximize this thing here, because this thing here is the base. So we want to maximize the distance between gamma and that, and the side lengths are parallel. So the furthest distance away, because it's the circle is symmetric. If it's on this corner on this side, or you could say perhaps actually even better, you could say this is gamma here. So this is gamma here. So this is going to be negative gamma. So there's a distance of 2 gamma in between them. And because of the circle's symmetric property, we can do that for every single quadrant of the circle. So again, we want to maximize the area between here and there. Again, this thing here is also a distance of 2 gamma, and then we keep doing it for this as well. It's not parallel nor straight, but it's fine. 2 gamma. And now we're trying to figure out, so we know that the rectangle, so the area of the rectangle is base times height. So area is equal to 2 gamma times by 2 gamma, because that's base times height. So 2 gamma. Area is equal to 4 gamma squared. But how do we get gamma? How do we involve gamma? How do we turn gamma into a number so we can find out the area of it? Because we have an expression for the area, but we want to find an actual number for it. So, what does this thing here mean? What does 25 mean right there? What does that mean? So it means that the radius of the circle is 5. So from this point to that point is 5. And similarly, because it's on the radius, there to there is 5. And imagine that this line is just a straight line going from there to there. If I do my circle properly, we can see that we have a triangle like this. And this is going to be 10. We also know that this angle here is a right angle because the side lengths are parallel, so they are orthogonal to each other. So this side length here, 2 gamma, it's also 2 gamma. And from Pythagoras' theorem, we can see that 2 gamma squared plus 2 gamma squared is equal to 100. So you see that we have 4 gamma plus 4 gamma, 8 gamma squared is equal to 100. And then 100 divided by 8 is 12.5. So gamma squared is equal to 12.5. That's pretty cool. We could try and maybe root this in, find the value for gamma, but we have gamma squared here. We take this value over to there. A is equal to 4, 12.5, A equal to 50. So I thought that was a really, really nice problem to do.